Today, we'll be deriving the vector dot product using law of cosines. My name is Ved Krishnan, and let's get started. So in the top left corner, I've given you the components of vectors u, v, and u minus v. The reason why I'm giving you these components is because we're trying to find the angle between two vectors. That is what the dot product is, finding the angle between two vectors. If you want to further get into the dot product and what it also is used to test if two vectors are orthogonal or parallel. Now what that means is orthogonal, if you don't know, is it's another way of saying perpendicular or normal. And I'm not going to necessarily get into that in this video, but once we actually derive the dot product from the law of cosines, it should sort of be common sense as to how you can test if two vectors are parallel or orthogonal. Think about the angle between two vectors. Anyway, so let's first recall the law of cosines. So the law of cosines, I'm going to try to write small here today because we have a lot to write. Law of cosines, that is, one way it can be represented is by c squared equals to a squared plus b squared minus 2ab cosine of angle C. Now you're probably like, why law of cosines? Why not law of sines? Well, of course, if you remember, law of cosines can only follow two criteria: side angle side triangle, or side triangle. So in this case, without even drawing a picture, it should be clearly evident, applying your knowledge of vectors and components, that this will be a side triangle using the given information on the top left corner. Because if we are given three vectors, right, and we know that the third vector is vector u minus v, and that will therefore form a triangle. If we are given all three components, in fact, if you're just given vector components of vector u and v, you can easily find the components of vector u minus v, and you'll get your triangle. If we're given components of a vector, we can find the magnitude, right? If we're given components of vector u and v, we can find the magnitude of vector u and v. So if we have the magnitude, we can represent it as a side of a triangle, and if we're given three sides of a triangle and we're trying to find the angle, that is law of cosines. And in this case, we're going to say that the magnitudes of u and v are going to be a and b, because the angle C, which we're going to denote as angle alpha, will be between the two vectors u and v and their magnitudes. So let me draw a picture that may have not made sense here. So we can say that this is vector v, and this is vector u, and this is vector u minus v. Okay, and then we can say that this is angle alpha. Okay, the angle between the two vectors. We're given the components, we have the picture, we can find the magnitudes easily, and we're going to have three magnitudes, which is the sides. Three sides is a triangle, and we're trying to find the angle between vectors v and u, or u and v. This is a clear law of cosine scenario. Okay, so hopefully that makes sense now that I've drawn a picture. But anyway, let us now substitute this in terms of our vectors. So we can say here that, let's first say C, right? C equals to the magnitude of u minus v, right? Just told you that. V equals to, or not v, sorry. A equals to the magnitude of v. B equals to the magnitude of u. You could also switch it around if you wanted. And we can say that angle C equals to alpha, because that's how it's usually denoted. as alpha, not c. So anyway, using this, let's put it into our law of cosine. So we'll get magnitude of u minus v squared equals to magnitude of v squared plus magnitude of u squared minus 2 magnitude of v magnitude of u cosine of alpha. Okay, and now going back to what I said earlier, if we're given components of a vector, we can find the magnitude. So what I mean by that is if we're, this is the x component and this is the y component, this will form a right triangle. So therefore, we can actually find the magnitude using the Pythagorean theorem. So what I mean, or the distance formula, however you want to view it. So understanding that, and hopefully you've already learned how to do that, or how the visualization of the x component and y component sort of thing. We can actually say here that let's first get the magnitude of u minus v in terms of x1, x2, y1, and y2. This will just be the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, and then squared. And then this will equal to the magnitude of v squared, which can be represented as x2 squared plus y2 squared, the square root of that, squared, plus then this will be the square root of x1 squared plus y1 squared. And then for minus 2 times magnitude of v, magnitude of u, cosine of alpha, we're actually going to keep that how it is. We're not going to worry about that. Okay. So we're going to do minus 2 magnitude of v, magnitude of u, cosine of alpha. Okay. So now we'll see here that the squares will cancel. And we'll get then x1 minus x2 the whole squared plus y1 minus y2 the whole squared equals to x2 squared plus y2 squared plus x1 squared plus y1 squared minus 2 magnitude of, I'm going to skip the parentheses. That's what I'm just going to write magnitude of v, magnitude of u, cosine of alpha. Okay, so now let's just expand. You see here, let's just expand these two right here. So then we'll get x1 squared minus 2x1 x2 plus x2 squared, and then same thing here, plus y1 squared minus 2y1 y2 plus y2 squared. This then equals to x2 squared plus y2 squared plus x1 squared plus y1 squared minus 2 magnitude of v, magnitude of u, cosine of alpha. Okay, so now we can just cancel out things that are the same on both sides. So this is the same, this is the same, this is the same, and this is the same. So now, again, I'm going to just to save some space here, we see that this is a 2, this is a negative 2, this is a negative 2, and this is a negative 2. So we can just cancel those out as well. Okay, just to save space here, sorry about that. So we can just cancel these out as well. So now we'll get x1, x2 plus y1, y2 equals to the magnitude of u, or I'm going to write it as magnitude of, yeah, we can just say magnitude of u, magnitude of v. It's the same as magnitude of v, magnitude of u, cosine of alpha. Let me put the therefore there. This is our dot product. Or you know what? Let me put the therefore after this, because it's actually the correct way to represent this is v dot w equals to x1, x2 plus y1, y2. Okay, so this is the notation here. This is not a multiplication sign. This is not a multiplication sign. This is a special notation for dot product. I'm not going to go all into the notation today because it's mostly just, first of all, understanding the dot product and how to derive it and what it's supposed to do. But then just understanding that this is the general notation is good to know, I guess. And then also v dot w, we can say, equals to the magnitude of u times the magnitude of v cosine of alpha. And but yeah, this is deriving the dot product using the law of cosines. Hopefully you now know where this comes from. Great.